Okay, we have a composite section, steel girder and the concrete on top. And after this, we're going to define 3 construction stages. As you can see, the stage 1, which is just constructing the columns, pier cap, and the abutments. And the second one, we are installing the girders, steel girders, and having the concrete on top of that, but concrete is wet yet, so it's gonna be only a dead load. And in the stage 3, we assume that the concrete is set and the section is behaving as a composite section. And then we get the result for all 3 stages separately. Okay, let me start the presentation by opening the Midas Civil. Okay, let me just check how is your view, then I can adjust this screen. Okay, I think this should be clear to everybody. All right. So as many of you may know, this is the general graphical user interface of Midas Civil, which with several toolbars in the top and the right side, and in the left side we have an important part called tree menu, which today we'll see that how easily it can help us for modeling and checking the our model. And down here we have a window message, which is the place that the software can communicate with the user. So if you do any mistakes or analysis is not going through, so we understand that what's the problem. Software actually tells us. Okay. So what I do, I quickly start with the defining the material. So for that, we're defining concrete material. So for that reason, right-click on the model view, go to the properties, material, and add. Selecting concrete, and then name it concrete 4000. From STM standard, going with the C4000, and here we have all the properties. Apply, and then the next one going to be steel with A53 and all the material. Apply, and then I need to define one more concrete material, which I'm going to use it only for the dummy beams. So for that reason, I need to use the same modulus of elasticity and Poisson ratio, but we have to set the weight density as 0. For that reason, I select this, and I have everything here. Then going back here to user define, and then setting it as 0. Okay, close. Now we have 3 material properties. Excuse me. I'm going to define some time-dependent material properties as well. So for that reason, going to the properties, time-dependent material properties for the creep and shrinkage. Add, and I call it C4000. And we have several codes which you can select. Now we go with the CB FIP 1990, but you can select any other one which you want to. And then for, I have to change my units to the kips and inch. So because I have the values in the kips and inch. Okay, C4000 and 4 KSI, humidity 70%, and the nominal side will be 100. You can change it later on. Alright, then show the results. So here you can see that for the creep and shrinkage, we got these 2 curves based on the code. Close and apply. So you can define as many as you want. So again, going to the property, now I'm going to define the time-dependent compressive strength of the concrete as well. So for that reason, going here, name it compressive strength, okay, based on the code. And again, I go to the CBFIP and for KSI and show the graph. So you see that this is created. So if it's not correct, so simply you know that your input are not correct and you can change them. Anyway, okay. Now we have our material defined. Now I'm going to define the sections. So for that reason, let me first define the composite section, go into the properties, and then the sections. Adding a new section. So here you have a variety of sections you can select. You can go with the user defined, you can go with the steel reinforced concrete, you can go with the combination of all those, or PSC, or tapered sections, or composite. Now we go with the composite. And this composite could be all these steel boxes, steel I composite, which will be concrete. Now we're selecting steel I and going to define this. All right, total width going to be 450, and then we're gonna have totally 4 girders, and the distances center to center going to be 102 inches. Again, here we're defining the slab for only this section, so it's 102, and the thickness of 8 and height of 1. Okay, and now here defining our girder. So the girder will be 34.5, 16, 16, I'm sorry, 16, TF 0.75, and the second thickness going to be 1. All right, so we need just to define our material. So, standard MC 4000, A53, and okay. All right, so we defined our composite section. Simply name it composite and apply. All right, now it's created here. The second one, I'm going to define the transverse sections. So that could be that's a rectangular section. So for that reason, I'm just selecting a solid rectangular, or go to the user define and name it transverse section. Okay. With the user defined, h going to be 8 inches and the width going to be 36. Okay, down here you can see your section and apply. Okay, for saving time, I'm going to import the rest of the sections which I already created in my other file. So if you have generated your sections in other file, so you can simply copy it from, import it from your other sections, so other file. Okay, so we have all stuff here, and then pressing OK. In the left side under the tree menu, you see that the new sections are generated, actually are imported from the other file. Okay. Now we're done with the material properties and the sections. Now is the time to define the geometry. Okay, for that reason, I'm going to use one of our wizards. So I start with beam. So there are several ways to create these. One of them is you can start from scratch, just defining all your nodes and then extrude them to the line elements and all those. Or another way is this one, using the wizard. Or if you have other wizard which is related to your type of project, simply we can use those wizards. Okay, so for this reason, I'm going to define that 60 times at 3 foot. So we're going to be 36 inches. And then selecting the material, going to be A53 and then composite section. All right, add. And you see everything is here. Okay, so now what I'm going to do, I need to translate these elements. So if I go to the top view, have CD. So okay, here you can click the hidden view, so it goes from the hidden to the 3D. So here's your section, and you can turn this on, turn it off. So anyway, go to the top view, and then selecting entirely all elements, and then translate them. Okay, translating them to the equal distances of 5 in the X direction, 8 in the Y direction, and 0 in the Z direction, and 3 times. Okay, copy that and apply. I'm sorry, I have to switch these to the foot. So now we're defining 5, 8, and 0 3 times, selecting all and apply. Okay, so you see that we defined also this skewness here. Now we have to translate the nodes. Going back to inches. Okay. Now I'm going to create the cross frames. Alright, for that reason I'm selecting entire the nodes here in the bottom, and then extruding the node to the element, and selecting the steel, actual concrete, and the transverse sections. Okay, and it could be from here to here, and the number of times will be 3 times. Apply, and you see we have all the sections created. Now is the time to define the pier caps. So for defining the pier cap, I need to excuse me. Okay. Now this is my section, and I need to do 2 things. One is the defining the cross frames, and another one will be defining those pier cap. So for that reason, let me just select define one of these for you. These nodes, I'm going to translate those nodes to the bottom. So okay, translate, and then -12, -30 inches, and the number of time going to be 1, and apply. So if I go switch to this view, you will see that these nodes are already created. Okay, so I'm going to just show it for one section, one time, and then after that we can take care of the rest of them. Then for the time constraint, we just open the another file which already has these elements. Okay, so if I go back to the top view and then select previous, and then activate only. Let me select them again. Okay, now need to select these, 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 and these. And we are just activating these, and if I back to this view, I have only these members, so I can simply create elements, then steel, and then cross frames, and then connecting these to these, these to these, these to these, these to these. And then when you created these, simply you can just copy paste them along your elements, or along the x-axis or y-axis, depends on the which direction are you interested in to do that. And you can see these sections looks like this. Okay, so the same thing we're going to do for entire thing. Okay, the same thing we can do for the pier columns. So for the piers, let me turn this off, and there is one element here, should not be rated. Okay, so for that one, I select these elements and nodes. Okay, and activating those. All right. So what I'm going to do, just generating these nodes down there. Again, the same process that I showed you. Okay, go to the nodes and then translate -30 again. Let's see, make it larger, -108 inches, and apply, and then going to the front view, and we have all the elements here. So what could we do? I'm going to generate one more to show you how it works. Okay, node, translate, in y direction, in this direction, to the half. Okay, so now I'm going to assign these sections to creating another element, and assigning this time I'm going to assign the concrete and the pier cap. So pier cap could be from here to here, we have here to here, and here to here. Okay, so if I show this, you will see that the pier cap, it doesn't look like how it should be, because it's a tapered section. So if I activate only these sections and show them, so for some reason, in the beginning it doesn't look like that, so we have to make it work. Therefore, okay, excuse me, I have a sore throat and it's kind of killing me. Okay, going to the properties and then the taper section group, and now here we have to name it. Let's say pier cap, and then elements. So we have to select these elements, and then linearly everything is okay, and press add, and you see that it becoming a taper shape. Just put them all in the align each other. Okay, close. So we can do the same thing for the rest of the structure. So let me activate all, and then open a new file from my folder, Okay. Okay, so this one has already, we already defined some other cross beams, and now we already defined this abutment also. Let me just quickly delete these and then show you how you can simply define these abutments. Okay, so what could we do? We just simply select, let me create this element from here to here, from here to here. Okay, so what could we do for defining the abutments is to we're just selecting the elements, line elements here, and then going to the elements and then extrude them. So this time we're extruding it from the line elements to the planar. Okay, we select our material properties, which is concrete, and then the thickness is the one that we already defined. I'll show you how to define that one as well. And then equal distances, we go with the negative 12 times and 39 times. Negative 12 inches and 39 times. So okay, press apply and you will see is created here. So we can make the model, modify that and then mesh it. But let me just open this and having all these created. Okay, so now we defined also these piles. So for piles, is exactly the same way. We're selecting these nodes and then extrude them. Now is the time to define the groups. For group, you can assign different elements and different boundary conditions to the different groups. So for that reason, you can simply select your structure, go back here, and then from your section, let's say composite section, and then coming to the group, creating name would be composite section. Add another one would be cross beams. Add pier. Add and so on and so forth. So just let me show you some. Here for composite section, you select the entire the composite section, then drag and drop it here. You see entire the elements, 240 elements are assigned to this structural group. The same thing for the boundary groups. And let me quickly define these boundaries as well for you. Okay. So for defining the boundary, you can we have two type of boundary I'm going to assign to these. One of them going to be the normal boundaries, like a normal supports. Going to be fixed in all directions, and just selecting some points from here on this node and this node, and then apply. So you can see we already defined it there. And for the abutment and also for the columns, we can define also the springs to have the solid structure interaction modeled there. So for that reason, I'm using a pin support, spring pin support default, and then add linear. And for these values, I'm going to use this value for the 8765 KSI. The same thing for the Y direction and slightly lesser for the Z direction. 36,786. Okay, and then for rotation I will keep it for 0 for now, And what I do, I just can simply select some of these and then apply. You see that they look different from these boundary supports. So simply you can see them here. If we display this, supports are looking green, and these one looking in yellow, so you can distinguish them. All right. Now it's the time to actually define these load groups. The loads. So just give me 1 second. Let me see if I have my. Okay, so let me open the new file. And then here I'm going to define these loads. Okay, for today, as I mentioned, we're going to apply the self-weight and temperature loads, and also we define the moving load later. So for that reason, going to the move loads, and then temperature load, temperature system, load case we define as a TS, and then type going to be temperature, add. Let me here define also the self-weight and that load, add, close. Okay, so here load case will be TS, default, and Fahrenheit, correct. Add, okay. Going to the load again, temperature loads, and then beam section temperature. Now here we can assign the temperature load to the our section. So okay, for that reason I'm selecting the PSC or composite section, and then we have to define that. So I have my temperature varying along the section. So for that reason I have to select one reference point. So for now, let's say stick with the top, and then I have my B as 0, H1 6, H1 0, H2 6, and then temperature 1 is 12, temperature 2 will be 0. Add. I have another loads here, so start from the bottom. So the first one, H1 going to be 0, H2 will be 6, and T1 will be 10, and T2 will be 5. Add. So we are assuming that the entire section are experiencing different temperatures. Okay, and the last one, H1 is 5, H2 is 10, temperature 1 is 5, and temperature 2 will be 0. Okay, add, and we need to select the entire our section. Let me go to the top view, and then selecting, let me select them in this way, then I'm ensure that I selected my girders. Okay. Okay, now apply. Apply and close. Okay. So now the next step is to actually activate the self-weight. Just go to the -1 in the Z direction, and add. And finally, we're going with the construction stages. As I told you, we're gonna have 3 construction stages. The first construction stage would be when we have our columns and the abutments. So for that reason, we just press this and add. Let me generate, let's say, construction stage, and then suffixes 1, 2, 3, 30 days, and OK. Okay, I can add it here. Name construction stage 1, duration 30 days, and we don't need any, we need additional steps of 20, which you can add it here. And then for that reason, in the elements, I'm going to add the substructure, add it. Sorry, I gotta give it the 30 days age, modify. And the boundaries, these are the groups that we already defined. So we're going to be only the supports, add, and then the load. We need to just activate the self weight for now. Add. Okay. Apply. So my first construction stages is created. You can see it here. So the second one, 30 days, the same thing. Only thing we're changing, we are adding the girders and cross frames. So girders and cross frames with the age of 30, age of 0. Boundaries, rigid links, add, and finally in the load. In a second stage is we are placing that girders, and we having the wet concrete on top of that, so it will be just the wet concrete. Added, and the scaffolding in the 20 is the additional steps. Add, and press apply. We go with the third one. That one also have 30 days duration. We don't need any additional steps for that. And then elements, we have to add the transverse beams in the 11 days. Add. Boundaries remain the same, and for the load we have to deactivate the wet concrete. So for that reason, wet concrete and the scaffolding goes to the deactivate. So in the right side we have in the left side we have activate, and the right side is the deactivation. So here we just at the end of this, the first day add, so it's already deactivated from the second stage, and we are activating the wearing course and barrier in the last day and add. Okay, so we already defined 3 construction stages. Okay, let me close that. Okay, there is one one last thing. Let me open this, and you see it in the tree menu. You can follow everything. So okay, the very last thing is to define the composite section to tell the software at which stage it has to activate it as how to behave it as a non-composite or the girder, and when software can take it as a composite. So for that reason, we adding this. So you have both of your components here. In stage 2, my first section of girder is activated, and normal. Okay. Alright, for here we selecting our material, and then the material property is steel, because our first thing is our eye girder, and then which stage is activated stage, or we can select the second one, or activated is the same thing. And for the second part, again going with the material, defining this as a concrete C400 4000, and it will be activated on the stage 3. Okay, and the age 11 is the same age that we defined for the construction stage 3 when we adding this, and the notational size of 0.2. Oh, 0.2. Okay, apply and close. Alright, this is also defined, and now we need to define the moving load, and then we will be ready for the performing the analysis. And close this. Alright, for defining the moving load, activate all. This way. Okay, for moving load, we need to just go to the load, moving load analysis, and the first step is to select the code. So for now we stick with the H2 LRFD, then okay. Now the software let me to go forward and then define the traffic lane lines. Okay, for defining the traffic lane, let me go to the top view and turn off this. Go to the hidden view, and now what I'm going to do, defining the traffic lanes. So for the traffic lane, let me, as I mentioned, we're gonna have 2 lanes. So the first lane, and then eccentricity 0, apply to the cross beams and the cross frames. Skewness, we have 30 degree of skewness in the beginning and at the end, backward, forward. And then 2 points, selecting 2 points from here to here. Is it correct? Let me just select it again. From here to here. Okay, it already exists. And apply. So what happened? I have to define it again, lane 1. The cross beams, cross frames, 2 points from here to here. Then elements, this point to this point. Okay. And then we're defining the second lane, going to be lane 2. The same thing, and skew 30 degree from here to here. Why my mouse doesn't work here? Add lane 2. Lane elements. Okay, from this point to this point. This to this. Okay. I don't know, for some reason my mouse doesn't work properly. And close. Okay, we defined our traffic lanes. You can see both of them. So next, go to the load again, moving load analysis, and this time we have to define our vehicle. So what I do, add from standard. So defining one trunk. Okay. Apply, and then I can take a one tendon also from H2LRFD. Okay. Stick with these 2, and then load, moving load analysis, and moving load cases. For the moving load cases, let's call it case 1, and then combination of those 2 and add. This opens it for me. So now I have select both lanes, add it, and the minimum of lane is going to be 1 and the maximum going to be 2, or we can stick with the 0 also, so it will be none of them. Okay, and alright, this for the tendon, and again the same thing for the truck, add 0 and 2, and okay, close. And now we are ready to perform the analysis. So for saving the time, I have my model, the analysis is completed. So I can open this for you, and just showing you the results. Here's my bridge, and all the loads, you can see them here, supports and moving loads. All right, so this is actually perform the analysis. Now I can get the results, show the results for you. Let me quickly go to the results and show you some of the deformations or the forces. Go with the beam diagram and selecting for the moving load analysis, or let's say first check it for the self weight, and having our legend and apply. Okay, so you can see that bending moments are shown for all elements, which are actually beam elements. Now the abutment is created from the plate elements, so we don't have any result on them, but we have to go to the beam results and check those out. So okay, for the moving load maximum, you can check this out and see the results for maximum bending moment, or you can check it for the shear forces. And the software has one unique feature which called moving load tracer, in which you can find out for a specific element what was the load pattern which caused that maximum effect on your structure. So that saves a lot of time for you, as well as you can save it as a static load, and then later on when you want to, when changing your sections, you can only perform static load, static analysis, which takes a very shorter time compared to this. Okay, let's check the temperature as well. Okay, for this is the result of the shear, but let me go to the moment. Result of the moment based on the temperature load, and the values you can see here are, these are maybe exaggerated, so you cannot just compare them to each other. So different ways to show the deformations, or not deformed form. Okay, now to get the stresses on the abutments, we go to the result, and then stresses, and then plane. Just go for the self weight and checking that. Okay, now you see that the other elements are gray, so it means that they are not activated and they are not plane, but you can see the stress contour on the abutment. Oops. Okay, and you can change it to the to see the different load cases on them. Different load results. Okay, from that side there's a different stresses. And one more thing I want to show you will be the moving load tracer. Okay, so for the moving load tracer, let's go with the beam forces. Okay, we can select one of the elements, let's say this element from here, size 23, and apply. And what you see here, this is the load pattern that causes the maximum moment in that element that we selected. So if you want to design your structure for let's say midsection here, midspan section here, so we can simply click on that and see what was the load pattern which caused that effect. So simply if I select another element, you will see that the load pattern will change. Okay. Okay, yeah, you can get also the result of the stresses and the deflections, deformation, and all those. And let me just show you how to extract the result in a tabular format if you are interested in. So you can simply click on this button in front of the beam diagram and then select for which load are you interested to get the result. Let's say we want the moving load maximum and moving load minimum, and then for entire the structure and apply. So you have this table in front of you, which is axial forces, shear, and bending moments and torsion. So what software does for you for the analysis control, I activated the to get the result of concurrent forces for the moving load analysis. So which means whenever you get the bending moment, maximum bending moment in one section, one element, what would be the corresponding axial forces on that element? So for that reason, you have all these here, and then you can sort this actually based on the like ascending or descending as you want. So sorting dialog. Let's go, I'm interested in the axial and the moment. Axial and the moment. And add it to the right side and then deactivate all these. Okay. And let me switch this up. Moment will be more important for me, and then sort it. When you're sorting that, you have all your data moment Y are in a ascending order, and let's say for the maximum bending moment which occurred for the as per moving load analysis was in this element 92, and then you can see the corresponding axial and shear and torsion in the this element when this happens. This maximum moment happens. So this is all for today, which I want to show you. I keep this session open for a while. And please send me your questions using this chat box, or you can send me an email on my contact here. So I turn off my microphone, and will be here for a couple of minutes, and if you have any question, please feel free to send it to me. Thank you so much. You have a great day.